Good morning, students. In this session, we are going to see what is process management, which is the second unit in the operating system. Myself, Dr. Shirisha, Associate Professor from CSC Department, MLR Institute of Technology. And for this unit also, the textbook that you have to follow is again the Galvin. 7th edition is okay. And this is other textbook, Advanced Programming in Unix Environment, is also okay. It is by William Stevens. And coming to the process concept, so process management includes several topics like what is process concept, what is process scheduling, what are the scheduling queues, what are the scheduling algorithms, and what are threadings, what is multi-threading, etc. So we start with what is process concept. Actually, we see what is actually a process, then we'll see how to schedule them. So coming to process concepts, an operating system executes a variety of programs. So what are the programs? Either using the batch systems, which are called as jobs, and time shared systems, they will execute as a user program or a task. So whatever the processor is going to execute, we can divide them in two ways, either as a job or either as a user program. So if it is a batch system, we call it as a job. If it is a time shared system, we call it as a user program. Only the terminology differs, but both are processes only. And whatever the Galvin we are using, the textbook follows job and process almost interchangeably, but the scenario is same. We are talking about the process itself. Now, what is a process? A process is a program in the execution. Program under execution we call it simply as a process. Process execution must progress in a sequential fashion. Sequential fashion is how a process can execute. Process 1 will execute, process 2 will execute, like that it goes sequentially. And what are the multiple parts of a process? In the process, when you consider, you have a program code also called as a text section. So this text section is what we call as simply the data. Then current activity including the program counter. So program counter is where it according to the user, the counter may increase or may decrease. If the counter is given as 5 and unless the counter becomes 0, the process will be executing. Okay, so that is use of the program counter. Process registers. So whatever the process we are saying, it includes the text section, it also includes the program counters. So you have several sections where a process is divided into and is maintained as a log, which we call it as a process control block, which we discuss in the next coming sessions. Stack. So what is stack? Stack containing the temporary data and function parameters, return addresses, local variables. So all these three, whatever related to the functions that we are using, so all that is maintained using the stack. Stack works as LIFO fashion, last in first out fashion. Then data section. So why we are divided into 1, 2, 3, 4, 5 different things is, here whenever you execute a process is stored in this fashion. Okay, sequential fashion. So in this sequence, the first will be the stack, then you will have a data section also where it contains the global variables. Global variables are those where the data can be accessed globally. They are not locally defined. Therefore, they can be accessed by any user globally. And heap contains the memory dynamically allocated during the runtime. So heap has one advantage where it can take any size of memory. Therefore, heap just it is used for dynamical allocation during the runtime. So these are the key terms. One is the text section where you store the program code, and program counter where you have to increment or decrement the counter according to the user requirement. Then the stack. In stack you have function parameters, return addresses, local variables, then data section and heap. So these are the 5 multiple parts a process is divided into. So let us see a diagram. where it shows all these 5. Okay, if you see this diagram, this is a diagram where it shows how a process is stored in the memory. So if you take in the memory, first is the text section that we have discussed, then data, then you'll have heap. So heap will be dynamically allocating, so you have some space up towards the heap, and firstly you will have the stack. So here you have a stack. Stack will be executed in the fashion last in first out, where it sends all the process that is entering into the memory. So this is how a process is stored in the memory. So if you see, a program is a passive entity stored on disk. Program, what is a program? Whatever the program code that you write, okay, set of instructions, okay, so that's nothing but a program. So it's a passive entity, means it has to be written and it has to generate an executable file. So then it can be compiled and executed. Without the executable file, you can't execute any program code. So that is the executable file. So we are calling that as a passive entity. Whereas process is an active entity. You are undergoing or you are executing the program is a process. Execution of a program is a process. Whereas program generating a executable file is a passive entity. Okay, there's a difference you have between the process and the program, and program becomes the process when executable file is loaded into the memory. Instead of loading, you have a program code, and this program code is located at somewhere, and if it is not loaded into the memory, can you execute this program code? No. What you have to do, you have to load it into the memory. So load it into the memory. Then this sort of execution happens for the program code, where the executable file is generated. So this is how passive and active differentiation for your process and the program. And nextly, we have execution of program started by a GUI mouse clicks or command line entry of its name, etc. So you can execute either using the command line, either using the GUI. If you go over the Linux operating system, we'll be using different commands. /a.out. What is /a.out? It is where in the Linux programming you are executing the program, okay. Whereas in the Windows, you will be having several commands for execution, okay. So like that, suppose if you take Java program, so Java C you will be compiling, then again Java you will be using for running the program. So that is how you will be using randomly like a command line, or you can directly go to the program, double click, like a HTML also is one example. So go to the program and just double click, it opens into the browser and you'll get the output in the browser. So that's a GUI interface it supports. So like that, it supports various things. And one program can be several processes. Yes, one program can be several processes. In what way? Suppose if you consider a program, you'll have a main method. It's one process, we can say. If you're writing one function 1, it is again a one more process. We can say process 1, process 2, multiple functions, multiple process. Okay. So like that, a program can have multiple process. And consider multiple users executing the same program. Multiple users executing the same program is a different scenario. Okay. So where it has to support a multiprocessing. So this is about basic information about the process. So we have seen this diagram where we have text, data, heap and stack. In this format, the data is going to store as a process in the memory. And coming to process state, once you know what is a process, we need to understand what is a process state. What is process state? As a process execute, it changes its state. That means what? You should have a process ready for execution. Once they are ready, they have to form a queue, ready queue. Then from the ready queue, if at all the resources are available, then from the ready queue to running state, the process has to go. Instead of going to the running state, if the resource is busy Then what happens? Your process has to be in the waiting state. Okay, you have a process, you have resources. Process, I am denoting it with circle, resource with a square. Suppose if you have a process, say P1, P2 and P3, if all these processes are ready for its execution, then we make it as a queue. Which one is the first in the queue? P1. If at all the resource is busy, all are in the waiting state. If at all this is in the idle state, not busy, then what we have to do? We have to give a chance for a process for its execution as the resources available. Okay, it is not busy. So there are different states like this. If you see here, first one, new. New is when a process has been created. Initially it will be in the new state. Then second one will be the running state. Instructions are going to be executed. Then third is a waiting state where you have resources are busy. Then you have process has to be wait for event to occur. For event to occur means it will send some instructions saying that a process can avail the resource. So the next is the ready state. The process is waiting to be assigned to the processor. That is, it is ready. Even if the resources are idle and your process is busy, not interested to get into the running state, then again it will go to the waiting state. We will see such scenarios with the help of diagram. So once it is ready and it has been to running state, then we have to go with the terminate state. The process has finished the execution. So this is how we have 5 different states. And this is the diagram which depicts all the states that we have discussed so far. So new is when a process is created. So once the process is created, it will go to the new state. Okay. Once it is new, it is admitted, then it will go to the ready state. And from ready state, you have two things. One is a scheduler dispatches to running state if it is ready, if a process is ready. Otherwise, after running state, if any interrupt occurs, again it will go back to the ready state. This is when something like when you are taking a print, okay. If power goes off, then what happens? It will again go back to the ready state. Again, when power comes, then it will go back to the running state and you'll get a print. It is something like that, okay. A process when interrupt occurs, it will be halted and preempted. Therefore, it goes back to the ready state. This is a cycle in between the ready state and the running state. Okay, once both the process and resources are available, now the process is ready to go to the running state. Clear? Next is from running to IO, input output or event. When you get an interrupt or input output here, then it will go to waiting state also. Either if interrupt occurs, it goes to the ready state, or any input or output operation is required, then either it may go to the waiting state also. So from running state, you have 3 outputs. If it is completed, it will go to terminated, that is exit. If it is not terminated, you got interrupt, it will go to ready. If it is getting some input, output or event should occur, then it is going to the waiting state. If that event occurs, again from waiting to ready and ready to running, it will go. So this is IO completed, so it will go to ready and then it will go to the running state. So this is how the state gets changes in the different scenarios, like when you get an interrupt, when you get an IO operation, or when you when it has to get some event, and when IO is completed, again it goes back to the ready state to the running state. Clear? So this is what a process diagram which shows different process states of a process. Okay. Hope you all understood. Thank you all.